Greetings everyone, and happy almost St. Patrick's Day. May the luck of the Irish be with you as you tackle this month's problem. There's sure to be a pot of gold at the end of the rainbow for all who work through it. Without further ado, let's get started. Today's Math Fix is brought to you by S-CP.A.5, which asks students to recognize and explain the concepts of conditional probability and independence in everyday language and everyday situations. Let's take a look at our problem today. Students are asked to help settle a disagreement between Parth and Nicole. Parth claims that his flights into Los Angeles are hardly ever on time. Nicole finds a table of values to support her claim that flights into Houston are even worse. Is Nicole correct? Let's find out. Nicole makes a misconception that students might make initially, which is simply adding up the number of on-time and late flights into Houston and LA between the two airlines shown, and noting that there are indeed more late flights into Houston than LA. However, Nicole isn't thinking about the probability here, simply the number of flights, which doesn't take into account that there are actually more flights, at least on these two airlines, into Houston than LA, which might skew the data. In this case, we need to consider the probability of a flight being on time and late into Houston and LA to actually determine who is correct. Here, to find the approximate probability that a randomly selected flight arriving in Houston will be on time, we must add together all of the on-time flights between airline A and B and divide by the total number of on-time and late flights on both airlines. Given this, the probability that a randomly selected flight arriving in Houston will be on time is 88%. Doing the same for LA, we get only 82%. To confirm, we can calculate the probability that a randomly selected flight arriving in each city will be late. Doing the calculations, we get, as expected, that the probability for Houston is 12% and LA is 18%. So it appears that Nicole was incorrect. There is a higher probability of a randomly selected flight arriving late into LA than Houston. One extension could be to ask students if the airline appears to make a difference. Although the airlines have different probabilities, on all fronts, Houston still fares better than LA. Another extension would be to ask students if the events arriving on time and LA are independent events, when you're comparing Houston and LA, and what that means in the context of this situation. Here, it would mean that the probability of arriving on time does not depend on which city the plane is arriving. Well, since the probabilities are very different, we can say that they are not independent events. Another extension would be to add Chicago into the mix and ask students if the events arriving on time and Chicago are independent events. Some calculations will show that if you are considering only Chicago and LA, you could say that yes, since the on-time percentages are very similar for Chicago and LA, the events are roughly independent. However, with Houston and Chicago, the answer would again be no. Finally, you might want students to consider in all of these what a significant percentage actually is and what constitutes about the same versus a significant difference. And that's this month's Math Fix task, folks. There's only one more Math Fix test for this year in April, so we can't wait to share it with you. Until next time.